Have you ever wanted to learn how to build your own distance sensor? Well, stay tuned because that's what we're going to go over in this tutorial. So, thank you for checking out this video. Be sure to like, comment, and subscribe if you enjoy this tutorial. And like I said before, we're going to be learning how to make our very own distance sensor using the Arduino microcontroller. So, how are we going to do this? Well, we're going to be using a ping ultrasonic sensor. And so you might be wondering what that is, but it's just a sensor that sends out an ultrasonic signal, and when that signal, it shoots straight out, and once that signal hits something, it bounces back and goes back into the ultrasonic sensor. And so that sensor reads how much time it took for that signal to go to and from itself. So once it's got that information, it's up to us as programmers to decide what we want to do with that information. So in this video we're going to learn what we're going to do. We're going to learn actually how to build our very own distance sensor, and we're also going to be revisiting a topic or a part, the piezo buzzer, which we used in our PIR sensor alarm tutorial. So if you want to check that out, it's a pretty cool video. It's going to be in the top right corner. So yeah, if you want to check that out, that's fine. And so yeah, we're going to be using that piezo buzzer to expand on this project. So let's get into the parts we're going to need to build this project. So for this project, you are going to need a breadboard, an Arduino. I'm using the Arduino Uno, a ping parallax ultrasonic sensor. It has 3 pins on the bottom, ground, 5 volts, and SIG, a piezo buzzer, and a handful of jumper cables. Okay guys, here we are in the programming part of this tutorial. So we're gonna jump right in, and at the top we're just gonna create a few variables of constant ints. And constant int is just means that these variables aren't gonna change values or anything, which you don't really need to put the const in, but I just did so I could explain what that meant. And we're gonna make for the ultrasonic sensor, which I named ping pin, and that's going to be on digital pin 7, and the piezo buzzer, which is going to be on digital pin 9. So then we're going to go down to the void setup, where we have something new we haven't seen before, which is serial.begin 9600. So we're going to come back to that, but first we're just going to go to pin mode, and then the piezo buzzer, which is an output, nothing we haven't done before. So let's go back up here, which is serial.begin 9600. So this basically opens the serial monitor, which is up here, and the serial monitor is how we're going to monitor our measurements in inches. So it's going to give us those measurements. And serial.begin 9600 just means that 9600 baud is going to be how fast the serial monitor is spitting values at us. So nothing too difficult there, it's just the speed at which it's outputting the values. So then we go down to the void loop, and here we have a new variable type called long, and that is just an extended variable size, which we're probably going to need if you're going to be measuring really long distances, of course if they're in inches. So we have duration here, which is the time it takes, and the time it takes for the signal to travel from and to, and inches, which of course is the measurement. So then we go to the pin mode, and at first the ping pin is going to be an output. So make sure you do not have this in the void setup, because later on in the void loop, the ping pin output, the pin mode is going to change. So make sure you have it in the void loop. Then we're going to have our digital write. Oh, actually, and the ping pin is going to be an output because it's going to be sending out a signal at first. So you can't be an input to do that. You have to be outputting something. So then we're going to have digital write ping pin low at first, so it can give us a clean signal, because the ultrasonic sensor needs 2 or more microseconds for it to send its signal. So then we have a delay microseconds of 2. So then finally we put the ping pin to high so it can send a signal out, and then we have it delay, so 5 microseconds, and then we stop the signal of the ping pin, or we turn the ping pin low. So then we go down here and the pin mode changes for the ping pin, and it becomes an input, because it now needs to take in the signal. So it's gonna be an input. So now we go over duration, which was our long variable, and it's gonna be equal to pulse in. And pulse in is just it reads inputs either high or low, in this case from the ping pin, which is now high because it's waiting for the signal from the signal that the ping pin released a few microseconds ago. Yeah, so pulse in just reads either high or low signals. So then we go to inches, and we're just changing the microsecond. We're giving. Okay, inches is the long of inches. The variable we created is gonna be microseconds, 2 inches, and duration, which is just saying that the time it takes is gonna the amount of time it took to travel is gonna be the distance it is. And then, as you can see here, is duration, which we named up here as pulse in, ping pin, and it's high. So then we go to serial.print and inches. So serial.print inches just means that it's just gonna print the variable, it's gonna print the variable inches. It's gonna print what the distance is in inches. So then we go to serial.print and then quotation mark in, and then quotation space, and then quotation mark. And so all that does is, after it displays the number of inches, it's gonna do a space, and then it's gonna be in, which is short for inch. And so that's just for ease of reading. And then serial.print line. So that means it just goes to the next line. And then we're gonna have the delay of 100. So then we go down to the buzzer part of this code. And the buzzer, in this case, it's gonna beep. It's gonna be off so let me just walk you through. So if the inches are more than 60, so if it's more than 60 inches, digital write, and then the buzzer is gonna be off. So if it's more than 5 feet, if something is more than 5 feet away, the buzzer is just gonna be off. So else if inches are less than 60, and double ampersand means and, inches is more than 48 inches, it's going to digital write, and then it's going to turn, the buzzer is going to be low, and then a delay of 1 second, then digital write, the buzzer is going to be high, or it's going to be on, and then delay 500, half a second. So this just means if inches are less than 5 feet, but they are greater than 4 feet, the buzzer is gonna start beeping, but slowly. Else if, and then the next else if says that if inches are less than 4 feet, but are greater than 3 feet, digital write buzzer low, but this time it's going to start beeping more rapidly with a delay of 500, and it's going to turn on with a delay of 500. So as you can see, each time it's getting faster and faster. And then else if inches are less than 3 feet but are more than 2 feet, it's going to beep even faster with only a delay of 200 milliseconds. So else if inches are less than 2 feet but are greater than 1 foot, digital write buzzer low, delay 100, and digital write buzzer high, delay 500. So it's beeping at its fastest right now. But else inches less than 12, digital write buzzer is just gonna stay on as long as the distance is less than 1 foot. So basically all this is doing is that the closer an object gets to this to this sensor, the piezo buzzer beats more rapidly each time it gets the closer it gets, and it slows down its beeps the farther away something gets. So that's just a little detail that I've included the piezo buzzer. You can make this more inches or less inches depending on how specific or broad you want these inches to be, but I just did this in forms of 1 foot each time. So then we reach the end of our code and we make another variable called long microseconds to inches, which we created up here, which was microseconds to inches. And it's going to be long, and we're going to create a new variable called microseconds. And so in this little snippet of code, it says return microseconds and then 74 divided by 2. So the reason this is here is this is the part of code that's actually going to be measuring the time, and it's going to be figuring out the distance. So as I said earlier, 74 microseconds, since if the signal travels 74 microseconds, it is 1 inch. But as you can tell, we need to divide it by 2, because 74 microseconds is from there and then back, but we don't want it when it comes back. We just want it to go there, and we want to measure that, so we divide it by 2 to find out how much time it took the sensor to reach the object the first time, and then we just want that value. So that's why we divide the 74 microseconds by 2. And so that's all that code does. It just tells us that, and then the top code knows what to do with that information, and then it transforms it to inches, and we display that on the serial monitor, and we use those inches in our favor with the buzzer. And that's basically all there is to it to write this code. So let's hop out of this computer and see what this code produces. Okay guys, so as you can see, I've connected my USB cable to my Arduino and to the computer. So let's go ahead and upload this sketch. And also I forgot to add that make sure that your pin for your piezo buzzer is not connected at first, otherwise you'll be greeted by beeping. But we're first gonna wanna check our distance sensor, so we're gonna leave that off first. So let's go over and we're gonna check on the distance. So let's upload this, and you're gonna see, well, first we're gonna look down at the sensor. So it's uploading, and so after it finishes, you see that light is blinking very rapidly, and that is every time it's taking a measurement, so it's going pretty fast. But let's go ahead and open our serial monitor, and let's take a look at our measurements. So let's go up here, and as you can see, we've got a steady 86 inches. So we can go ahead and test that. You could just put your hand at a certain distance away from the sensor. So as you can see, my hand is getting closer and closer. And as you can see, the distance between my hand and the sensor went down, and once I took it away, it went back up to 86 inches. So we can now look that the sensor works pretty well. So now let's connect our piezo buzzer. Let's go ahead and connect that. So we're going to go over here, take that, and we're going to connect it over on pin 9. So as you can see, it slowed down because there's nothing in front of it, and it turned off because of the code we put in it. So now we can go back up here, and we see that it's still around 87 or 85. Okay, so now that we've tested our distance sensor, let's now test the actual beep of the piezo buzzer. So as we did in the code, as the closer we get, the faster it should beep. So let's check it out. So we're start off here, and it starts slowly, but as we move closer, and it stays on. But as we move back away, it goes back to normal until it fully stops when I get out of the way. And that's basically how that works. So that's about all there is to it, guys. So thanks for watching this video. Be sure to like, comment, and subscribe if you enjoyed it. And be sure to check out my other Arduino tutorials, and I've even started some C programming tutorials, so they're going to be in the top right corner again. So make sure you check those out. And so that's basically all I have for you guys. So see you in the next episode, guys. Bye-bye.